welcome to collaborate. So for each problem, you will have time to do it. After 10 minutes, whatever, then I'll do it. So this way, not only you have a chance to try on your own, then you compare your solution with my solution. That's the best way to prepare. I also got some inquiries about, do I have to memorize? No, you don't have to memorize formulas or anything like that. So if it comes down to you don't remember a formula or something, I will write it on the board. So this way everybody will have the opportunity, even if one of you asks for a formula, and that's something that it's reasonable, I will write it on the board, so not only the person who asked, but everybody else has the chance to see. So let's go ahead and, I'm not going to wait anymore, so let's get started. So I'm going to get started where we ended last time. So where we ended last time was a problem from project management. So let me draw, and as I said last week, and I reiterate today, the graph will be given. So where does the problem start? The problem starts where we're given a graph, and the question is to find out how long it's going to take to complete that graph. So let me use exactly the same problem that I had last time. So let me draw it, and then I'll show you the method, how we can determine how long it's going to take. So the first step is to draw the graph.
What's this called?
Project management. That was project management. Okay, here it is. So this is what I drew on the board last time. I took it a step earlier, where it was given in a table format, and I converted the table into a graph. But the starting point of the problem that you have to solve in the exam next week is this point. That means a graph will be given like this. So that graph represents a project. So what is the question? The question is to find out how long it's going to take us to complete this project. So that's the question. How long it's going to take to complete the project? So there is a quick way to get the answer, which works only for small projects. That means let's do complete enumeration. Let's find out how many paths we have, compute the time it takes to complete each one of those paths, and select the longest path, because as I said, the longest path determines the length, the duration of the program. So let's do it that way. Works only when we have a small problem like this one. But then I'm going to show you a method, a more mathematical, scientific method that works for any project, even if you have thousands of activities. Right now, for a small project like this, we can cheat. We can find out how long it's going to take by enumerating all possible paths. What constitutes a path? Just look, it's very easy to see if you are looking at it. A path is a walk from 1 to 6. So how many different ways we have to walk from 1 to 6? Let's enumerate them using the letters, the activities. 1, 2, 3 is missing here. 4, 5, 6. Everything else is okay. Okay, a path, as I said, is a continuous walk from 1 to 6. So how many different ways do we have to get from 1 to 6? 3. So one way is A, B, F. Next, another one is A, C, E, G. One more, B, E, G. Which one?
A, C, E, G.
A, C, E, G. Yeah, I listed this one here.
B, C,
B, C. Okay, here. This is not, but let me see again, everybody. B, C, remember, those are one way. B, we cannot go up on C. Remember, there's an arrow pointing down. So BC, not a valid one, because treat it as a one-way street, so we cannot go back there. So that's it. Okay, for a small problem, as I said, you just list. When I say enumerate, list each one of those paths. So for each one of them, we can figure out what is the length. So if we take the first one, ADF, we just add the lengths. 10 plus 13 plus 12. 35. This we did last week, but just one continuity. Let me just do this part. A, C, E, G, 10, 15, 19, 33. B, E, G, 11, 25. Okay, and last week I told you, if we were solving a shortest path problem, what is the shortest path from 1 to 6? The answer, of course, is 25. But this is not the problem on hand. The problem on hand is how long it's going to take to complete the project. The project is completed only when all the activities are completed. So which one of those paths will decide the completion time of the project? The longest one. Yeah. Because you can finish the shortest, but the project is not done. The project is done when everything is done. So which path determines the length of the program, of the project? The longest one. And I told you, in project management terminology, there is a specific term for the longest path. The longest path is called critical path. So I said, let me write it so you know. The longest path, so in this case is this one, is called the critical path. This is a standard term in project management. So the longest path is always called the critical path. So if somebody asks you, what is the critical path in a project? Answer. The critical path is the longest path. So the longest path is the critical path. Now, as I said, this is what we call it a quick way to get the answer, and it works for small projects. Why? Because if you have a small project, visually you can enumerate, you can list all the paths and figure out which one is the longest. In real-life project management, you have projects which have thousands of activities. So when you have thousands of activities, you cannot enumerate it. So in that case, there must be a scientific way to do it. So that's our next and final topic for this class. I'm going to show you how can we determine the length of the completion time, the length of a project, and how we can also determine, of course, which path is the longest path in a scientific way. That means even if the project has thousands of activities. So I'll do it here slowly so everybody can follow the steps. So what we're going to do, for each one of those points, we call them the nodes, we're going to draw a cross. So those crosses, each cross corresponds to one of those points. So 1, 2, 3, another one here, 4, 5, 6. So for each node, the formal term for each one of those circuits, it's a node. So for each node, we draw a cross. And we're going to do a forward pass. That means we're going to walk from 1, 2, 3, 4, 5, 6. And then we're going to do a backward pass, walking backwards from 6 all the way to 1. When we finish both the forward and the backward pass, we'll be able at that time to determine the length of the project and also which path is the critical path. So that's how we're going to do it, as I said, in a systematic way. Because the enumeration works, one more time, if it's a small problem like this one. But if it's a big one, it doesn't. Okay, let me show you how it works. Forward pass. Yes?
For the time it takes to complete each project, do you, let's say if it's in hours, do you add the hours? Or do you add
that's what I did here. For example, as I said, let's assume each one of them is hours.
Right.
So when we start, we can start A and B concurrently. Remember, at this point, we start both A and B. So one crew works on A.
Right.
It's going to take 10 hours to get there.
Okay.
Another crew works on B. It's going to take them 7 hours to get there.
Okay.
When this one finishes, can we start, when this A finishes, another crew starts working on C, 5 hours.
Right.
So, when can we start E? Only when both B and C are finished. Please understand the meaning of those arrows. So those arrows imply what we call precedence relations. What does it mean? Certain activities cannot start until other activities have already been completed. So for example, here we say, how many hours we need to do it? 4 hours. When can we start it? We can start it only when both B and C are finished. At this point, we don't know when it's going to happen, but that's what we're going to figure out by doing it in a systematic way. But please understand what is the meaning of those arrows. Those arrows, each arrow represents an activity. An activity is part of the project. But why do we need those circles? Those circles are points in time. So what is the interpretation of number 3? Number 3 is a point in time. We'll figure out how long from the beginning in a few minutes. But what is the interpretation? When both B and C are completed, we can start working on it. Please understand this. If you don't understand this, it's going to look like a mathematical exercise.
It's like a production where in order to complete...
So it means certain activities, and I used a very good example. From construction management. We say, when can you start building the walls? When you finish the foundation. Then I said, when can you start building the roof? When you finish the walls. When can you start the plumbing? When, again, you finish the walls. So that's the reason each one of those, if you use an example from construction management, what does it mean? A project is to build a house. A house is, in order to build a house, you have to build certain parts. Walls, foundation, roof, plumbing, electric. Can we do it in any order? No. Certain things must be done before other things. That's exactly what this says. So for example, here we say E can be started only when B and C are done. How about D? D can be started only when A is done. Somebody's going to say, what about, why don't you need C before D? No, I don't, because C is pointing this way. If you look at 2, 2 is the ending of A, and at the same time, the beginning of C and D. So C and D can start immediately after A has been completed. Same thing down there. When can we start F? Only after D has been completed. So that's how it works. So
What is C effect?
Say that again?
What's the C effect?
Like a different product?
He said like what?
C is just an activity, and each one of them here is some, as I said, depends what is the real interpretation of this. If it's a house, as I said, it's part of building the house. If it's a software project, as I said, project management is usually associated with construction or sometimes software development. So those are, if it's a software development, each one of them is a module. It's a module of the program. And when can we say the whole thing is done? The whole thing is done when both F and G are completed. When both F and G are completed, finished. The whole project is done. But you have to understand the arrows. The arrows tell us that certain activities must be completed before other activities start. What is the mathematical term for this? Precedence relations. We call those precedence relations. Certain activities must precede other activities. When can we declare the project completed? At point number 6. So the project is completed when we get there. So what are we trying to do? We're trying to figure out, if we start at time 0, I'm just putting the first number over there on the top left. We always start at time 0. If we start at time 0, how long is it going to take us to get over here? Now, we already know the answer if we did it, as I said, by trying each one of the paths. We know the answer. The correct answer is 35. But what we're trying to do, we're trying to determine this number in a more formal way. But I'm saying, if we cannot visualize how many paths, and we have to do it the hard way, one step at a time, how long, if we start at time 0 here, we try to figure out how long it's going to take us to get over there. So now I already know the answer. What is the correct answer? We have to get the 35. But we have to do it again to confirm that 35 is the right answer. All right. So as I said, we're going to do it in 2 steps. In the first step, we're going to start from 1, and we're going to keep on going forward. Forward means from 1, we'll go to 2, to 3, to 4, to 5, to 6. To figure out how long it's going to take us to get to 6. And then we're going to do everything in reverse. We start from 6, and we're going to go 5, 4, etc. But let's go forward first. Going forward, starting from 1. The next point is 2. 1, 2, 3. As I said, we're going to do it in the order, in the natural order. 1, 2, 3, 4, 5, 6. How long is it going to take us to get to 2 if we start at 1, at 0?
10.
10. Because 0 plus 10, is there a link between 1 and 2? Yes, there is a link. And how long? The link is A. What is the length of A? 10. So 0 plus 10, 10. I'm only doing the top left. Only the top left. Ignore the rest. Each cross, only the top left. So
There's a whole early start, early finish.
yes, that's what we're getting.
Okay.
So it's only the top left that I'm working on. Only the top left. So I said, starting at 1,
Okay.
at point number 1 at 0. Can I get to 2 going forward? Yes, because there is a link between 1 and 2. The link is A. Since the length of A is 10, it's going to take me 0 plus 10 equal 10. Now, here is where I need your attention, because for point 3, how can we get to 3 going forward? You have to look to understand what I'm saying. There are 2 ways to get to 3. One way is to get from 1. If we choose this path from 1, it's going to take 0 plus 7. Why 7? Because 7 is the length of B. So one way is 0 plus 7, which is of course 7. But there is another way to get to 3 from 2. That's the reason you need to look at the graph. There is a way to get to 3 from 2. If we follow this path, how long is it going to take us to get there? 10 plus 5,
15.
15. Now, remember what I said. What is our objective? To figure out what is the longest path. Since we're looking for the longest path, when we have more than one option to get to a point, which number do we choose? The longer one. So instead of writing, so we have to write either 7 or 15. So which number do we choose? 15. Because again, the idea is to write the longer one. All right, so now I'm halfway through going forward. So I'm already at 3. So I have to go to 4, and then 5, and finally 6. So next point is 4. How long is it going to take me to get to 4 going forward? Again, look at the graph. Is there a link between 4 and a previous point? Yes, there is a link between 2 and 4. And what is the link? D. What is the length of D? How long is that? 13. So how long is it going to take to get there from 2? 10, the point which is the value at
Plus
2,
13.
plus 13, 23. Again, looking at the graph, we're looking at the graph to figure out if there is a link between the point that we want and any previous point. A link, of course, is just an arrow, an activity. That's the reason for each activity we have the length. So this way we know how to get there. Next, 1, 2, 3, 4, 5. The next one is 5. Is there a link between 5 and a previous point? Yes, 3 to 5. So how long is it going to take us to get there?
19.
The value at 3 is 15. Plus 4?
19.
19.
I have a question.
Yes.
From 1 to 3, it's 7.
No.
Oh,
There are
okay.
2 ways to get there. So I
Right.
said from 1
Right.
to 3. One way is 0 plus 7. But
Okay,
there is
okay.
another one. 10 plus 5, 15.
Oh,
and I said
okay.
when there is more than one way to get to a certain point,
It's the longest.
the longest. Because we're looking for the longest path, we choose the longest.
Okay.
Now, 4 and 5, there were no comparisons. There was just one way to get here. The same issue we have now at 6. At 6, we have the same issue.
Mm.
How can we get into 6 when we go forward? There are 2 ways to get to 6 going forward. One way is to get there from 4. So if we choose the
Which
path
is the
from
longest
4,
one?
the value will be 23. Let me write both. 23 plus 12,
It's
35. But there is another way to get to 6 going forward from
19.
5.
19 and 14.
If we choose the value from 5, it will be 19 plus 14,
33.
33. Okay, whenever we have a choice, what do I
35.
say? The longest.
longest.
So we're going to choose 35. So there are 2 values that get us there, so we're going to choose 35. Okay, it looks like we're on the right track as far as getting the correct number, because remember when we did it by enumeration, by trying all possible paths, we said 35. So 35 is the value we got, but we cannot declare it as being the correct value until we do the other half. So the other half is to say, starting at 35, I'm going to intentionally use a different color. So now we'll say, starting at, so what I do now, I say the top right, the top left was 35. So now what I'm going to do, I'm going to fill in the top right. But now going backwards. So if I ended up with a 35, I start with a 35. So if I do it right, starting with a 35, when I'm all the way back there, what should I end up with? A 0. A 0. A 0.
Yeah.
So I said, if we start with a 35, and I do it right, I have to walk all the way back. Now I'm going to walk back. Remember, I went forward, 1, 2, 3, 4, 5, 6. I'm going to go backwards. So backwards means in which order should I consider the nodes? 6, 5, 4, 3, 2, 1. So everything in reverse. So now I'm going to do everything in reverse. I'm going to start with 6. From 6, I'm going to go to 5, to 4, to 3, to 2, to 1. So everything will be done in
It's
reverse.
gonna match. It's gonna match.
And if it's right, if I start with a 35, I should end up down here with what? With a 0.
35 from 6 to 5. 35 minus 19 will be the 14, which is also the G, right?
Yeah, we'll see that. As I said, we have to.
Oh no, it's not gonna be that.
So now the second half. So
Yeah.
the second half. So what is the second half? The second half is we start from the terminal point. So we start with 6. Look at, I used two different colors,
Yeah, you
the
did.
blue and the black. So on the terminal point, we say top left and top right, same number. We ended up with a 35, we put a 35. So the blue numbers will be ignored on the way back. It's going to be just a new set of numbers.
Oh, okay.
It's going to be a brand new set of numbers, the black numbers. So the blue numbers are irrelevant. I just use the last one as a starting point. So I put a 35. So I'm going to fill the top right with new numbers. But I'm not going to take into account the blue numbers. So the blue numbers right now are irrelevant. So I'm going to do it using, again, only 35 as the value associated with 6.
So in other words, you're going to use 35 plus 12 and 35.
No, now I'm going to be subtracting. I'm going to
Yeah.
put 35 going down. I'm going to be going down from 35, and if I do it right, I should end up with a 0 at 1. So the idea is now subtracting, going backwards. So I started with a 35, and I'm going to be subtracting. And if I do it right, I should be able to end up with a 0.
Does that only apply to the critical path though? Walking back?
Yeah, that will enable me to identify the critical
Okay.
path.
Okay, that's why it makes sense.
So we started from 6 with a 35. So remember what I said, everything is done in reverse. From 6 to 5, so 5 is there. Can we go from 6 to 5? Yeah, going backwards. If we walk backwards on an activity, can we get there? Yes, because there is a connection between 5 and 6, G. So 35, the black 35, minus 14 is how much? 33.
Yeah.
Okay, so the value here,
20.
23, I'm sorry.
21.
21.
21, thank you.
That's okay. It happens.
21.
Minus 14.
So you see what happened now? I say I'm going backwards from 6 to 5. Is there a link between 6 and 5? G. What is the value? 14. So 35 minus 14, 21. So that's how it works now. So we're going in reverse. Everything is done in reverse.
Wait a minute, you said that you're going to pick the largest number to go backwards.
No. As I said, there are two things. I said this as a starting point. Remember, we ended up at 6. The value was 35. So I said, automatically, I put a 35 there. And now I say, going backwards, I'm starting from 6 to 5. If you go backwards, I'm going to subtract the values. I said, I start with a 35. What is the length of G? 14. So, can I go from 6 to 5? Just think about a walk in reverse. Can you go from 6 to 5? Yes, if you walk against traffic on G. Remember, G is one way going this way. But I say, if you walk against traffic on G, how long is it going to take you to get to 5? 35 minus 14, 21. Next point, remember, now I do everything in reverse, from 6 to 5, from 5 to 4, 4. How long is can I go to 4 from 6? How can I get to 4 going backwards? There is a link from 6 to 4. So I can get to 4 from 6 going backwards. How long is it going to take? 35 minus 12, 23. 6, 5, 4. What is the next point going backwards? 3. How can I get to 3 going backwards? Is there a link between 3 and a higher point? Yes, there is a link between 3 and 5. So how can I get to 3 going backwards? From 5. Again, looking at 3.
17.
Is there a link
21
between 3 and a
minus
higher?
4.
Yeah. 21
Minus 4.
minus 4,
4,
17.
17.
Okay, so why do you have on the bottom ones 15 and 17 and on top ones
ones you have like the same numbers, 35 and 35 and 23 and 23?
Because remember,
It's just wait, let me. It's coincident. In some cases, the numbers will match. In some cases, like here, the numbers don't match. But the question is, how do we get the blue numbers? We already know them when we were going forward. The black numbers is when we say start from there and say and go backwards from 6 to 5. How can we get from 6 to 5? Yes, 35 minus 14, 21.
because remember, 30,
Then 4. Can we go from 6 to 4? 35 minus 12, 23. The key is 3. Can we get to 3 going backwards? Yes, 21 minus 4, 17. Here's the now. The next one is where I need everybody's attention. Can we get to 2 going backwards? Look at the first time. There are 2 ways to get to 2 going backwards.
yes, 3 and 4.
So
Yeah.
now I want everybody's attention. Can we get to 2 going backwards? Yes, but there is more than one way. So now, since everything is done in reverse, I'm going to try both ways, and I'm going to select a smaller value.
Okay.
Remember, when we go forward, it was the larger value. Since we're doing everything in reverse, how can we get to 2 going backwards? We can get to 2 from 3. Look at this link. Going backwards from 3 to 2, the value will be 17 minus 5. So one way is 17 minus 5, which is 12. Right? But we get to 2 going backwards from 4. So the value is 23, but be careful. Which 23? The black 23. It's only the black numbers now, the ones on the right. The black 23. 23 minus 13, which is 10. Again, everything is done in reverse. So when we had more than one option going forward, we set the larger value. Now when we have more than one option going back, what do we choose? Smaller value.
Yeah.
So we're going to choose the smaller value. So the value that we're going to assign over here is the value 10. Okay. After 2, what is the next point going back? 1. How do we can get to 1 going backwards? Again, 2 different ways to get there. So we can get to 1 from 2, you can get to 1 from 3. So one way is to get there from 2. So if we choose the path from 2 to 1, 10,
Yeah.
but which 10? The black one. 10 minus 10, 0. And the other option is to get to 1 from 3. The value will be 17 minus 7. Then,
What happens with it if they're equal?
either one.
So, Professor, overall.
Just let me finish. Give me a few minutes because now we're almost there.
Okay.
So again, what is the rule? Going backwards, the smaller number. So the smaller number between 0 and 10, obviously in this case we choose the 0, and the 0 is posted there. Okay, let's pause for a minute. First of all, I give you a strong hint. If you are able, when you go back to end up with a 0, this is a very strong hint that everything is right. You haven't done any calculation error. So if you do it right, when you go back, you must end up with a 0. Remember, you started with a 0, you reach 35. Then going backwards, if you start from 35, you have to reach 0. So this is a very strong indicator, the fact that we ended up with a 0, that we did it right. Because you have to end up with a 0. Remember how it works, it's symmetric. Starting with 0, you got to 35. Well, if you go back from 35, if you walk everything in reverse, from 35 you have to go back to 0. So now we have answered one question. How long is it going to take to complete the project? 35. Somebody's going to ask me, wait a minute, didn't you know that when we reach 6 to 35? Yeah, but at that time I was not sure. Now I'm sure because I was able to do it in reverse. Starting with 35, I ended up with a 0. So now I know 35 is right. So the first answer that we can write on the board right now is that the project completion time is 35. Project. So that's the standard terminology. Project completion time equal 35. So now I can confirm it, that 35 is the project completion time. How about the other half of the question? There were 2 questions. How long is it going to take to complete the project, and what is the critical path? So we have already answered the first question. That's going to take 35 time units to complete the project. Where is the critical path? So now I have to show you how we can identify the critical path. So there is a rule that we don't need to do any extra work. It's already there, but we need to know the rule. So what is the rule for an activity? The critical path will be a path. So what is the rule for an activity to be on the critical path? An activity, so let's take a generic one. So we take a generic one. So activity, and we put some value here, the length, x. So an activity with some length is on the critical path if the following is true. We have an, look at what I did. I said, if an activity is on the critical path, the following conditions must be true. On the start, the activity, this one starts here, ends there, okay? On the starting point, on this point, the values must be equal. You look at what I put. I put kk, the same number. And here, where it ends, the values also must be the same, ll. And more important, the difference, this number minus this number equals the length of the activity. So for an activity to be on part of the critical path, three conditions must be true. What is the first condition? Where the activity starts, there must be two equal numbers. Second condition, where the activity ends,
Wait, you said again?
yeah, let me repeat. An activity is part of the critical path if the following conditions are met. First condition, on the starting point, the two numbers are equal. You see this number? Kk are just any number, but it's the same number. Where the activity ends, on this point, the two numbers are equal. That's the second condition. So the first condition, equal numbers on the starting point. The second condition, also equal numbers on the terminal point. And the third condition, the difference between this number, L, minus K, should be equal to the length of the activity. So three conditions. Equal numbers on the starting point, equal numbers on the terminal point, and the difference, L minus K, should be equal to the length of the activity. So now let me check the activities one by one to see if they are on the critical path. Let's start with A. Is A on the critical path? Okay, let's check the conditions. First condition, we must have equal numbers on the starting point. What is the starting point for A? 1. A starts at 1. When I say starting point, is where it starts. A starts at 1. Do we have equal numbers at 1? Yes, 0, 0. Second condition, we need equal numbers at the ending point. So where does A ends? At 2. Do we have equal numbers at 2? Yes, 10, 10. So the first two conditions are true. Last condition, the difference, 10 minus 0 should be equal to the length of the activity. 10 minus 0 is equal to 10. So all three conditions are true. So one more time, for each activity, we're going to ask the question, is this activity part of the critical path? Answer, it is if all three conditions are true. What are the three conditions? Where it starts, let's take A. Where does it start? At 1. Do we have equal numbers at 1? Yes. Check mark. So the first condition is met. Next condition. Where the activity ends, in this case A ends at 2. We must have equal numbers. Do we have equal numbers at 2? 10 and 10 equal. Yes. Third condition. The value there, remember you put generic K and L. The value there, so in this case 10 minus the value K, here, the K, which is 0, should be equal to the length of the activity. So 10 minus 0 is 10. So all three conditions are true. So we say A satisfies all three conditions to be on the critical path. So A is on the critical path. So I just put a scribble here, just a check mark, something that A is on the critical path. Let's repeat. So we're going to repeat it for each activity. Is B on the critical path?
No.
No. Okay. First of all, remember what all conditions must be true. So even though this is true, B starts from 1 and equal numbers, but B ends at 3 and we have unequal numbers. One condition is violated, stop the search. So we say B cannot be on the critical path because one condition has been violated. Which condition was violated? That the ending point of B, which is 3, has unequal numbers. So one condition is violated, B cannot be on the critical path.
In business terms, why do we need to know which one's the critical path?
I'll tell you when we finish. So when we finish, you'll see that there is a reason, and it's a practical reason. I can preempt the answer right now to give you a more theoretical answer. the critical path is the one that is tight. There is no room for error. So what do you do there? You put all your best people if you want, or you put the most people. On the other hand, if there is a non-critical activity, you can free up some resources from there. So let's assume you have 10 people working on a non-critical activity. I'll show you, instead of having 10, you can have 9 or 8 or 7 and still be able to finish it on time. So that's the reason, to reallocate personnel. So on activities on the critical path, things are tight. There is no room for error. So if there are floating workers, you put them there. On the other hand, the reverse. If there are if you know which activities are non-critical, you can move some people away from there. You can free up personnel from there and reallocate them, reassign them to other activities. So the practical answer is that knowing which activities are critical enables you to shift around people, especially in a situation where you have floating workers. So if you have floating workers, you take them away from non-critical activities and reassign them to critical activities. That's a short answer. So the longer answer is when I finish. So B is not on the critical path because of the unequal numbers. Next is C. Is C part of the critical path? For the same reason, the answer is no. Even though we have equal numbers at 2, it ends at 3 unequal numbers. Next is D. Is D on the critical path?
Yes, it is.
Yes. All 3 conditions are true. Again, this is an opportunity for you to practice the conditions. D starts at 2. Starting point is 2. Do we have equal numbers? Yes, 10 and 10. D ends at 4, so the ending point is 4. Do we have equal numbers at 4?
Yes.
Yes, 23, 23. Last condition, is the difference 23 minus 4 equal to the length of D?
Yes.
23 minus 4 is 13, which matches the length of D. So check mark. D is on the critical path. Next, E. Is E on the critical path?
No.
No. First condition is we need equal numbers where E starts. E starts at where? At 3. An equal number. So the rest is we don't need to check. Remember, all conditions must be true. If one condition is not true, we say that's it. That activity cannot be critical.
In a nutshell, walking forward basically identifies how long the project will take.
Yeah, and
And
going
then
backwards verifies
Right,
that
the
what you
critical
did
path.
is correct.
You verify the critical path?
Verify the critical path and that the calculations are also correct.
Just want to make sure. Thank you.
Okay, we did, where am I? D, E, E. Have we E?
Yes. E is not critical.
Is cannot because it starts at 3 unequal numbers. F is F on the critical path.
Yes.
Okay, starts at 4, equal numbers at 4. Ends at 6, equal numbers at 6. And the last one, 35 minus 23 is 12, which matches the length of F. So yes, F is on the critical path. Is G on the critical path?
No.
No, starts at 5 and we have unequal numbers. The minute you have unequal numbers somewhere, that's it. Alright, so now we're almost there. That means we have answered both questions. So the first question was how long it's going to take to complete the project, the 35, which we knew a few minutes ago. And the second question was to figure out what is the critical path. So now we have identified the critical path. So somebody's going to say, okay, this is, because right now I want to give you, somebody already asked me, what is the practical usefulness of knowing all of this? So let me give you now some addition, let me elaborate on your question with numbers. So let's take, if we have a critical activity, that means there is no room for error. But let's take B, which is non-critical. When is the earliest we can start it? 0. When is the latest we can finish it? 17. So the earliest we can start it is the value on the left here, 0. The latest we can finish it is that 17 down there. So look at how much leeway we have with B. From 0 to 17 is 17 time units. But the actual length of B is only 7. So now we quantify how much slack we have. So we say we have a time window from 0 to 17, but it actually takes only 7 time units. So we have a cushion of 10 time units. So now this is very useful information. So what does it mean practically? Practically means, let's assume you have 10 people working at B. So let's assume you say, let's take half of them away. So if we take half of them away, instead of doing it in 7 time units, how long is it going to take? Double. It's going to go up to 14. I can tell you, we're not going to do it, but I'm telling you what is the practical implication of knowing how much slack we have. From 0 to 17, we have a time window of 17 units. But B takes only 7. So there is a cushion of 10. Why 10? The difference. 0 from 17 to 17 minus 7 is 10. That cushion means if you raise the length of B from 7 to 17, if you slow it down if you want. If I said instead of trying to finish it at 7, you say let me add 10 to go as high as 17. If you replace that 7 with 17 and keep everything else the same, that 35 is going to still be the same.
And if you were to start at 11, then you'd be.
Then you violate. The
by
cushion
1
is 10.
unit.
If you
By
go
1
to
unit.
11, then it's going to be late by 1 unit. That's very good to understand. So that cushion, the formal term is slack. So that cushion, the slack, enables the manager to know by how long you're going to slow down, you're going to, for how much cushion, for how much time, by how much time you can slow down an activity, you can delay if you want an activity, without delaying the project. So this is the practical application of knowing that value. That means here it says there is a time window of 17, but the actual length is 7, so the cushion is 10. You can increase the 7 by 10. That means you can make it anywhere from 7 to 17, and still you're going to be able to be on time, provided that everything else stays the same. So this is the practical information that project managers take away from this. That means specific numbers, how long we can slow down an activity without slowing down the project. How do you slow down an activity? By freeing up workers working on it. So you free up workers and you reallocate them to somewhere else. So this is very useful, especially, let's say, construction management. So those construction workers are multi-talented. Some of them, they are not necessarily doing one type of work. They can do more than one type of work. So that's the reason, if you know these things, you move them around. You say, instead of working on this one, just go and work on that one.
They really, construction managers really use this formula?
Yeah, it's called, actually, this is, let me give you some terminology. The method, this method is called PERT CPM. Both of them are acronyms. So CPM is called both of those words are acronyms. CPM stands for Critical Path Method, which is this. So CPM stands, let me write the whole thing, critical. So this stands for Critical Path Method. Okay, PER. What does it stand for? Project
Headache.
Evaluation and Review Technique. Since you like history, you need to know where this was developed. This was developed in 1960. It's not that old. I mean, in scientific terms, it's not old. 1960, and it was developed by the U.S. Navy for the nuclear submarine program.
Wow.
So it was first implemented by the U.S. Navy in the nuclear submarine program. It was declassified around 7 years later, and then was converted to civilian use. In civilian use, as I said, the primary industries where it is used is construction, and also it's used sometimes, as I said, in software development. Now, obviously, do they do it by hand? Of course not. So what are the commercial software available which is built on this? The easiest one that most of you are familiar with is Microsoft Project Manager. So Microsoft has a program, it's called Microsoft Project Manager, which is visual. You see all of those things, you just put some numbers and all of this pops up. Now, construction management is more sophisticated, and the program that they use is called Primavera. If you heard of it, Primavera is the software that construction managers are using. All of those programs use this, built on this. But they have nice interface, they have graphics, you don't do numbers. And those two are the ones that I'm familiar with. Microsoft Project Manager is not that hard. I mean, if somebody is good with Windows, it's going to take very little training to do that. Primavera is more sophisticated.
How do you obtain the values that are used in this?
Okay, again, here.
I'm saying, like, the activities, the values, the amount of time.
How do you know the 10
Yeah,
units?
like,
Okay. Estimates. So right now I just put a number, but in
real life,
in real life, in the commercial software, you put You make a guess.
Okay.
Most likely, they have 3 values. They ask you for 3 values: optimistic, pessimistic, most likely.
Okay.
So they say, give me what do you think under normal operating conditions? We call it most likely. And then we say, if things go wrong, how long is it going to take? Pessimistic. If things go
Perfect.
right, how long is it going to take? Optimistic. So they ask for 3 values:
Professor,
smallest, highest, and something in the middle.
That's
when you're
interesting.
using Microsoft Project Manager or Primavera, does it ask you to know what's the critical path?
No, it's going to find it out for you.
Okay.
And the other thing they do, something else.
You
This
plug
is
it all in.
static. I took a snapshot. So let me tell you in real life what happens. Let's assume things go wrong here, and automatically this instead of 7 becomes 15. When, as you go on, you enter the real values and it updates. And it updates. That's what. So that's.
Can we use that for the test?
I'm putting Primavera on my laptop.
It's dynamic. The real one is dynamic. That means things go wrong. Let me tell you construction. What happens in construction? Knock on wood, we don't have many lately. Hurricanes.
Yeah, hurricane.
So then you automatically update.
Floods.
They go in and they update. When you have a weather event, everything slows down. So you go in and you update the values. Sometimes even a downpour in the summer slows down construction.
Oh, yes.
I mean, you're not going to continue working when you have pouring rain. So the software, the commercial software, is able to update.
In that case, you don't want to wait if you have a lag time or a lag time of 7. You don't want to wait till 10 to start your work because if it starts raining, you're
Exactly. Usually,
unforeseen.
the information here, this is just for practical purposes. Knowing this number is to use these numbers to reallocate workers. Okay. Yeah. Yes.
Why did you use the 17 just as slack of 10 instead of 15?
Excellent point. That's the rule. The rule is value on the right here, value on the left there. It's just a definition. 15, there is interpretation for it, but I don't want to go into it. But that's the definition. Smallest value on the right, this way. On the left, highest on the right.
To determine the slack.
Yeah, to determine the slack.
We use the highest number.
The highest number. For example, in this case, back to B. 0, 17. 0 is the smallest, 17 is the highest. So 17 minus 7, which is the length of B, the slack is 10. Okay, what I want to do is, we're done with material, so what you're going to be asked to do in the exam next week is I'm going to give you the graph, and I'm going to ask you 2 questions. First question, do the forward and the backward pass to answer 2 questions. One question is, what is the project completion time? Answer is this number, whatever number is here. And second question, what is the critical path? So what I want to do is 5 minutes only, 5 minutes break, and then we'll start the review.
Okay.
So we'll come back in 5 minutes to start the review.
The number you pointed out.
Okay.
The max, the